Academy for competitive exams. Welcome again the aspirants of Neet and IIT JEE Chemistry and the students of 11th and 12th standard to the post number 2 on isomerism. In this content, we will look at functional isomerism. Already, as you are aware, structural isomerism is of the following types: chain isomerism, position isomerism, functional isomerism, metamerism, TAUTOMERISM, and ring chain isomerism. In the last post, we have seen chain and position isomerism. In this post, we will see functional isomerism. That is, different compounds having same molecular formula but different functional groups are said to exhibit functional isomerism. That is, different compounds having the same molecular formula but they said to possess a different functional group. Such a type of compounds said to exhibit functional isomerism. For example, ethers exhibit functional isomerism with alcohols. We may expect the product to be an ether and also to be an alcohol. For example, a compound of molecular formula C2H6O, that is 2 atoms of carbon, 6 atoms of hydrogen and 1 atom of oxygen. The possible alcohol is ethanol, that is ethyl alcohol, CH3CH2OH. Also, it can be a ether functional group compound too, that is CH3OCH3, dimethyl ether, that is the IUPAC name methoxymethane. That is, ethers exhibit functional isomerism with alcohols. The second example is aldehydes exhibit functional isomerism with ketones. Aldehydes exhibit functional isomerism with ketones. For example, a compound of molecular formula C3H6O. The possible aldehyde is propanol, that is CH3CH2CHO, propanaldehyde with the common name. For a ketone, the possibility is propanone, CH3C double bond O CH3, that is acetone is the commercial name, and propanone. Another possibility is carboxylic acid also exhibits functional isomerism with esters. Carboxylic acid also exhibits functional isomerism with esters. Consider a compound of molecular formula C3H6O2. C3H6O2. The possible carboxylic acid is propionic acid, that is propionic acid, the IUPAC name CH3CH2COOH. 3 carbon atoms, hence we can slash E from propane and add OIC such that the name is propionic acid. Esters, the possible ester is methyl acetate, CH3COOCH3. So again I repeat, my dear students, ethers exhibit functional isomerism with alcohols, aldehydes exhibit functional isomerism with ketones, carboxylic acids also exhibit functional isomerism with esters. Now we come to the next type of isomerism, metamerism. This type of isomerism is not exhibited by all functional groups. It arises due to unequal distribution of carbon atoms on either side of the functional group. Again I repeat, unequal distribution of carbon atoms on either side of the functional groups. That is, different alkyl groups on different side of the functional group. Different alkyl groups on either side of the functional group. Ketones, ethers, esters and secondary amines exhibit this kind of isomerism. My dear student, in the last concluded Neet exam which took place in the year 2021, one question has come from the topic of metamerism. One question has come from the topic of metamerism. Okay, now we go to the example. C4H10O, the compound, the given molecular formula of the compound C4H10O. The possible esters are diethyl ether, that is CH3CH2OCH2CH3. On either side we got an ethyl group, hence the name diethyl ether. The other possibility is one side we may have a methyl group CH3, on another side of the ether oxygen we may have a propyl group, that is CH3O CH2 CH2 CH3, hence the name is methyl propyl ether. There is another possibility too, methyl we can group on one side and isopropyl group on the other side, that is CH3O CH3 bonded to the chain ends with another methyl group, that is methyl isopropyl ether. Again, we can give one more example to a compound of molecular formula C5H10O. We may have, in the case of ketones, the first possibility is pentanone with the carbonyl carbon coming in the middle position on either side, that is CH3, CH2, C double bond O, CH2, CH3. Hence the name 3-pentanone, pentane 3-one. We may again write the ketonic functional group on the second carbon from left hand side. Hence the name 2-pentanone or pent-2-one. The other possibility is we can drop a methyl group from the linear chain, that is CH3, C double bond O, CH3, the chain ending with a methyl group. The name is 3-methyl-2-butanone, that is but-2-one. 3-methyl-2-butanone. How come 2? Least number is to be given to the functional group. From left hand side, we assign the position 2 to the ketonic functional group and we drop a methyl from the third carbon. Hence the name 3-methyl-butanone. However, the common name is methyl isopropyl ketone. Now we move to the penultimate tautomerism, that is the last but one isomerism, that is tautomerism. So it's a special type of functional isomerism in which a single compound exists in two readily interconvertible structures. That is, the structures are highly interconvertible. These interconvertible structures differ only in the relative position of an atomic nucleus. Most preferably, the atomic nucleus can be an atomic hydrogen or atomic nitrogen, or in exceptional cases, some other elements. It is of two types: dyad system, triad system. Dyad, as the name implies to you, it oscillates between two atoms. It oscillates between two atoms. In this system, atomic nuclei oscillates between two polyvalent atoms. What is the meaning of the word polyvalent? Where the valency is more than 2. Hence the name polyvalent. For example, the first one, hydrogen cyanide, HCN. Hydrogen is bonded to the tetravalent carbon. In the second case, hydrogen is bonded to the trivalent nitrogen. Hence, the hydrogen atom, which is the atomic nuclei here, oscillates between carbon and nitrogen polyvalent atoms. The next example is triad system. In this system, hydrogen atom oscillates between three polyvalent atoms. That is 1,3 migration. The best example is keto-enol tautomerism. We have taken acetaldehyde. How can we write acetaldehyde? HCH2CHO. That is, we are, for simplification of structures, we are separately writing the acidic hydrogen in methyl, CH3, we are writing as HCH2, such that the hydrogen moves from position 1, migrates from position 1 to position 3, which is the oxygen. So the second form obtained is CH2 double bond COHH. That is, it is in enol form. The first form is a keto form, which is the most stable form with the yield 100%. The enol form is a minor product with a trace amount. So hydrogen oscillates or move from carbon 1 to the third atom. That is 1,3 migration shift. Next is nitroacid tautomerism. The acid form is that otherwise called by the term nitrate form, HONO. Here too, the hydrogen oscillates. Here you may see HNO2. That is what form? Nitro form. Here the oxygen atom, hydrogen in the first case is bonded to oxygen atom. In the second case, the hydrogen is bonded to nitrogen atom. That is acid and nitro form. They are in equilibrium to one another and are readily interconvertible. Now coming to the last type of isomerism, ring chain isomerism. Compounds having same molecular formula but differs in the number of bonding of carbon atoms to form either a open chain or a cyclic structure. Example 1, the compound of molecular formula C3H6. The open chain structure can be a propene, that is one propene, CH3CH double bond CH2, or it can be a cyclic structure CH2CH2CH2 like a triangle, that is cyclobutane. either propene or cyclopropane. The propene is what? A chain like type compound. The cyclopropane is a ring type compound. Another example is C4H8. The open chain structure is 2-butene. 2 indicates the position of the double bond on either side. 2-butene. Butene means it is a double bond carbon atom. Yes. Next, the other possible cyclic structure is cyclobutane in the form of a square. CH2, 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 CH2. Cyclobutane. That is the same compound may exhibit as a open chain structure or as a cyclic structure. That is a ring structure. Dear students, thank you for viewing our post. Our next post will cover how to crack Neet, and we'll discuss the content related to homolytic and heterolytic cleavage. Homolytic and heterolytic cleavage. Thank you and have a great day.